I've read only two novels by Andrea Camilleri, and one of those is called The Shape of Water. That by chance is the title of a famous movie made by the American filmmaker Del Toro that I suppose many of you will remember, and that tells the story of a young woman who falls in love with a strange creature who is half man and half amphibian. The love story is very poetic, but at the same time disturbing, since this guy, because of this diversity, is subjected to cruel experiments and tests. Even if the movie won the Oscar for the best film, I didn't like it very much, but of course this is only my opinion and not the absolute truth. On the other hand, I loved the novel by Camilleri because it's compelling and ironic to the right point, and so I recommend it. Anyway, all this preamble just to introduce today's topic. Today, in fact, we will try to give shape to the water, and more specifically to the processed water that are involved along the ceramic production lines. We will try to investigate the reasons why they are essential and why they may be sometimes the origin of critical issues. I am Davide Trentini, and this is Apparently Invisible: Chemistry in Ceramic. Let's start, as usual, from the beginning by saying that processed waters play a very important role in the ceramic production, since they are involved in many steps of the process, and they are also essential for the proper development of any single stage. But already there is a but. Even if they are fundamental, processed water can lead sometimes to serious problems when they do not have the proper features. So, let's try to explore these scenarios. As we know, ceramic production is a closed-cycle system where processed waters come mainly from in-house production activities. We are essentially talking about wastewater, mainly deriving from the grinding department as well as from the post-firing activities, such as, for example, cutting and polishing. This means that ceramic producers tend to recycle water both to keep cost and to reduce the environmental impact, a question that now more than ever is extremely relevant, and this is quite obvious. Together with this recycle activity, it is also important to take into consideration all waters that do not come from the company itself, but from outside. What kind of water are we talking about? We are basically talking about mains water, that it is important to underline it, is a water controlled and stable over time, mainly used in the glaze grinding department. And about well water, that instead needs, of course, more detailed inspections. In general, processed waters are made of a very heterogeneous mix, and this mix can include some components that we could define as dangerous, or even better, that can be the origin of the critical issues that we are going to address. What are these components? The most important for sure are glue and glaze residue, chemicals and raw materials residue. But how do these elements affect the application, and how can they interact with the processes? Let's try to say it in simple words. The presence of organic matter in the processed waters, together with its exposure to the air, may enrich over time the waters both of bacterial colonies and microorganisms, leading to very rapid degradations. Bacterial degradations may produce in turn, and this is very, very important, a significant increase of water electrical conductivity, that we could define as the ability of a liquid to carry an electrical current. But let's go deeper. The conductivity value is directly affected by the water's content of ions. We could generally say that the greater is the content of ions, or of the ionic charge, the higher is the water conductivity. But why is it so important to constantly check the values of the water conductivity? Let's make it simple by saying that a high conductivity water can be a problem because it may negatively affect the application, any kind of application I mean. For example, it may improperly act on the viscosity of the slurry or of the glaze. In some cases, the conductivity reaches such high levels that to proceed with a proper application, it is necessary to add more water in the process, and this, of course, affects in a negative way both the productivity as well as the environment. In fact, the increase of water content per kilos obviously reduces the solid rate of the suspension, leading to a lower hourly production of spray-dried powder during the atomization process. And this lower hourly production, together with the higher amount of water, leads in turn to a more important energy cost, also promoting a higher production of CO2. In other words, since we have more water that must evaporate, we produce more emissions. Critical issues promoted by the electric conductivity of water are also related to groundwater that, since it comes from deep under the ground, undergoes by its nature to changes according to the season. During summer, for example, the huge withdrawal of groundwater, together with the less frequent rains, can lead to a dip in the water's level and therefore to an increase in the ionic concentration, and so in the conductivity. And it's not by chance that problems related to high conductivity mostly take place at the end of the summer month. Anyway, what do we have to do when processed waters are affected by the problems that we have pointed out? First, we can surely say that processed waters often need different kinds of treatments to perform at the best and avoid production issues. These treatments can be different from company to company according to the specific production parameter in use, and the water clarification process is for sure one of those. And we can describe it, to make it simple, as a three-step process that develops through a flocculation and decantation phase, followed by a filter pressing process of the suspended particles that are in the water. And the most important suspended particles that are in the water, we have already said that, but it's important to repeat it, are glue and glaze residue, chemicals, and raw materials residue. Beside the water clarification process, it would be important to proceed with a detailed study of the water cycle to properly act with a sanitizing and preservation process. The main target is obviously to break down microorganisms and bacteria by means of a proper preservative and sanitizing agents. A grinding water that contains bacteria may, for example, lead to a bacterial proliferation inside the slurry after the grinding process, and the situation could get even worse thanks to the slurry's organic content, that is clearly food for bacteria. It is also very important to check the water basic parameters and especially its pH value. These controls are important to make adjustment in case of very non-standard parameters. In our case, the ideal water's pH value is about 8.5. A too acid pH, for example, could worsen the slurry viscosity, therefore affecting the application. With this last suggestion, with which we have tried to give shape to the water, the episode ends here. Hoping to have given you some food for thought, I want to thank you for staying with us, and I remind you, once again, that all podcasts are available not only on the main platform like Spotify or Apple and Google Podcasts, but also on our app that you can download for free on Apple Store or Google Play. Just need to type Z&S Ceramco or Apparently Invisible. Together with Camilleri, Guillermo del Toro and the water in all its shapes, I greet you all. We talk soon.